gone through stationary waves. I've told you there is a big difference between a stationary wave and the progressive wave. First thing is progressive waves are actually the way of passing the energy, or you can say energy is transferred along the waves, right? While in a stationary wave, energy is stored, not transferred. The reason is very simple, because actually stationary waves are formed when two waves of the same frequency and amplitude but traveling in the opposite direction superimpose or superpose to each other. Okay. So when they superpose to each other, then actually your standing waves or stationary waves are formed, right? So you can say that it is achieved by its reflection. So it's usually achieved by traveling wave and its reflection. So superposition produce a wave pattern where the peaks and troughs do not form. All right. So what exactly what exactly formed over there? I'll show you. If you see this wave here, you can see here it's a sort of a loop which is formed here. So these are called nodes, and the maximum position are called as antinodes. What are nodes in that case? We normally call nodes where displacement with respect to the mean position is 0, and antinodes are the points where displacement from the mean position is maximum, right? Now, what is the
Right.
difference? So now, what is a quick difference, one by one? Alicia and Zoha, can you quickly tell me? The first one is the energy store, and the other one do not store the energy. What is the first one or second one?
Stationary waves have nodes and antinodes. Progressive don't.
Absolutely. Then we have
Progressive waves have the same amplitude, and stationary waves have different amplitudes.
it depends on suppose what superposition they have it. And the most important part is the wave speed is the speed at which the wave moves through a medium, that is progressive wave. While on the other side, each point on the wave oscillates at a different speed. So overall wave does not move, technically speaking. Another very, yeah.
I don't actually understand that point you just said. What do you mean by overall the wave is not moving?
See, when you're talking about the wave motion, so wave motion is technically like that. Like it's a wave through the medium. If medium is there, wave is continuously going like this. But here it's actually under the boundary, right? It's not moving. What exactly is happening? For example, if this is your string or a string, whatever, the wave goes to the end point and then it reflects back technically. So it's a forming a loop. It's not a proper wave. Wave has to travel through the medium. It's traveling, but it's reflecting back. Previously, we didn't see any wave reflecting back. Okay. So, but here, wave is reflecting back. That's the reason what I'm saying is that the wave speed is the speed at which the wave moves through the medium. Here, wave is not moving through the medium. Overall speed, I mean, wave is not moving, but we can say each point on the wave oscillate at a different speed. Overall wave does not move. It will remain there because it is reflecting back, technically. Overall, why I'm saying overall, it goes there and comes back with the same amplitude. So actually, they are canceling the effect of each other. So overall, if you want to say that, overall wave is not moving. Okay. And one of the most important differences, one wave is actually, I mean, if I say that this point, let's suppose, then this point is lambda distance away from each other, right? Within 0 and 360 degrees. On the other side, point between nodes are in phase. Let's suppose these are the points, nodes. They are all in phase. But for example, if let's suppose the waves are a bit more passing through, then if you're talking about beyond this node, then this point and this point, they're out of the phase. Like for example, if you got this wave, right? If I say so, this is your node and this is your node. These all points what are here are in phase. But if you are talking about this point and this point, they are not in phase. So that's what they're saying. Point between nodes are in phase, but point on the either side of the node are not in phase, but out of the phase. All right.
Okay.
That were the difference between these two. Now at this point, we will prepare you for the superposition, and then we will go to young double slit experiment. That is the last topic I have done with Mahnoor yesterday. For that, actually, if you want to see the recording, I want you to go through the recording as well, because on Monday, we will also go through some of the topic related to young double slit, and then we'll pass to another very important topic for diffraction grading, right? Okay, now.
Wait, sir,
Mhm.
sir, at the beginning, my internet kind of glitched. So when are we joining Mahnur? On Monday?
Monday, hopefully. All right.
Okay.
Monday at 11, hopefully. All right. Now, which? Okay. Now, once we understand with these stationary things and how now at this point, this is important to go through the superposition. Now, what is superposition? Let's see. There is a term called superposition. When you say superposition, it means one wave onto another wave. That's what it means. Like, for example, you got these two waves. One is in blue and one is in red. If they superposition on each other, it means that there will be two conditions. One condition is, let's suppose you got these two waves. Let's suppose this is wave 1. And there is another wave. This is wave 2. There are two positions these waves gonna superimpose or superpose on each other. One is one wave crust fall on the other wave crust, and trough falls on other wave trough. And the other condition is one wave crust will fall on the trough of the other wave. Now remember that when crust fall on a crust, you will have an interference. And that interference will be constructive interference. Now, why constructive interference? Because actually, constructive. Now, why I call this constructive interference? Because from the mean position, the resultant amplitude will increase. So this is called constructive interference. On that side, there is an interference in which both the amplitude cancel the effect of each other. So there will be no amplitude, or amplitude will be 0. We call this destructive interference. So what is meant by constructive or destructive interference? Now I'll read it for you, then you will understand it yourself. Two waves that have amplitude of one traveling opposite directions. Now they actually showed it. And what they showed it, let's see. Where is my pen? Okay. Now check this out. I'll read it for you, and then you tell me if you have any problem in understanding. When two similar waves traveling in opposite direction, they can supposed to form a standing wave. Hence is the experiment setup of how we can form a standing wave on the string. That is for the standing wave, actually. Now, important thing which we have it here. Superposition wave is just like when you superpose one wave onto another wave. Okay. Now, remember that for actually superposition, it is important that one wave will fall on the other wave. Now, check this out. Can you tell me what is this interference?
Destructive.
This is destructive because as a whole, the displacement or amplitude of the resultant wave is 0. But for this one, if you see that, the resultant amplitude of the wave is actually increased, right? So that is what we called as superposition. If you check this out here one wave is a bit ahead of the other wave. So here you can't say it's properly constructive interference or destructive interference. They are a bit far away from each other. So what is the difference here between the two waves? We called it phase difference. So if 101% two waves are not in phase, then it's difficult to judge whether it's a constructive interference or a destructive interference. But still, some part is actually superposed to the other wave and some part is not, but there is a phase difference here. That's what I wanted to say at this point. Okay. Now, let me show you some more details here. It is for the sake of, now check this out. Now, what is harmonic? That's where the point is. Check it out. This is for the standing wave. Now, let's find out the calculation respective to the standing wave. Let me rub that, then you will understand. Now, let's have a standing wave here. How many waves are these, by the way? One wave going and one wave coming, right? Can I say that?
Half a wave.
Half a wave. So can I say that lambda 2 is equal to L? L is the length of a string. Can I say that?
Yeah.
So lambda will be equal to 2L. Right?
Mm-hmm.
This, how many loops are there? One loop. Can I write it like this? Lambda is equal to 2L upon 1. Yes, I can write it, right? Now check it out if there are two loops in that. How many, what is the lambda value in that case? One wave.
One.
So it will be L, right? Can I write it like this? Lambda is equal to 2L upon 2.
Yes.
Okay, this one. How many lambda do you have it? One
and
lambda?
a half.
1.5. 1.5 means
3/2.
3 by 2 lambda is equal to L. So lambda is equal to 2 by 3L. Now how many loops? 1, 2, 3. So this way, actually, if you proceed it, you check one thing. 2L is continuously common. So can I say that if there are n loops, it will be 2L upon n? Can I say that?
Yeah.
So you found out a wavelength formula for n number of loops, because length you mostly know that. Only you need to put the n value here and you will find out the lambda. Right? That formula will be when you are restricted to both the points. You can't proceed. If one point is free, the other point is not free, then this is not the formula. Now this is lambda. If I ask you, what is the frequency? So frequency is equal to F is equal to, V is equal to frequency lambda. Can I say that? So V is equal to frequency lambda. Now lambda is equal to V upon F. Right? This is the formula, you have it. If you want to find the frequency, let me just rub that. Can I rub that?
Yeah.
Okay, now check it out. We are actually going to find out the frequency. So frequency is equal to F is equal to V upon L. L means lambda. Okay. So basically, you can say V upon lambda. I'm sorry, not V upon L, V upon M, because the formula is actually V is equal to frequency lambda. So lambda is equal to V upon F, or if you want to find F, then it will be V upon lambda. Now, what you can simply put the value of V into this. So it is F is equal to V divided by 2L upon N. So formula for the frequency will be NV upon 2L. Now this is the frequency formula for nth number of the loop. You will place here n value, let's suppose 1. It will be F is equal to V upon 2L. That is for one loop. If you place 2 here, it will be 2V upon 2L. It is for frequency 2. If you place it for F3, it will be 3V upon 2V. So this is the frequency for nth number of loop value. All right.
All right.
Now here at this point, I want to mention one more thing here. Your F1 value, in which there is only one loop, we call this one, the frequency we called it, or F1 frequency we called is first harmonic. In which you got two loops, we called it second harmonic. Now in which there are three loops, we called it third harmonic. This is all frequencies we are talking about. F1 is first harmonic, F2 is second harmonic, F3 is third harmonic, F4 is fourth harmonic. Right? Understood?
Yes.
Now
Yes.
at this point, I want to tell you another thing. Harmonic start from the first frequency. There is another term which is used sometimes, we call it overtones. Remember that your first overtone start from second harmonic. So your F2 frequency is your first harmonic. So second harmonic is equal to first overtone. Third harmonic, your second overtone. Fourth harmonic, your third overtone. So harmonic is one extra harmonic value. I mean, overtone is one extra harmonic. Except F1, your harmonic start from second loop. Your overtone start from second loop, while your harmonic start from first one loop only, right? So these
Right.
terms will, yeah, you're asking anything?
No.
Okay. Now at this point, I think your harmonic concept is clear as well as overtone concept is confirmed. Now, if, for example, if I ask you, find me the value of or frequency value for fourth overtone, what exactly it means? Fourth overtone.
Fifth harmonic.
Fourth overtone.
Fifth harmonic.
Fifth harmonic.
Right.
It means n value will be 5, right?
Right.
Because the formula which is actually written here, it's with respect to harmonic, not with respect to overtone. We know that what overtone is all about, right? Okay. Now, another very interesting formula which actually this covers. There are two further formulas. One is generalized formula for the lambda n, which is equal to 2L upon n. This is for lambda. For Fn, you will have Nv upon 2L. And then you have another formula. Your nth, Fnth will be equal to Nf1. If you know the first harmonic, you can easily find out the nth frequency of nth loop. These three formulas,
Example?
like for example, if you have first harmonic value is equal to, let's suppose, 25 Hertz. If I ask you, what will be the frequency when the n number or the number of loops in a standing wave are 5? You don't have to calculate it separately. Simply 5 multiplied by 25 will give you the answer. That's it.
Oh, okay.
So you don't have to actually use the second formula. You just need to use the third formula if the harmonic or first harmonic value will be given to you.
So that 5 times 25 is equal to the n, which one?
Fnth, F5.
Okay.
Because in some question, they may not give you the length of string or anything. They just give you the fundamental frequency and they ask you to find fifth order or n is equal to 5. stationary, what do you call that, frequency, or n is equal to something frequency, you simply need to multiply that n value with the f1 and you get your answer. Right?
Right.
Now this question, can you solve that? A stationary wave made from a string vibrating the third harmonic has a frequency of 150 hertz. Calculate the frequency of fifth harmonic. Try this. They only provided you the harmonics, so you have to use that formula in some way or another. Try that.
Is it 750?
750. How did you do this, by the way? They give you,
150 times.
see, they give you F3 value, which is equal to 150. Am I right?
Yeah.
And they ask you to find out F5.
Oh, okay.
First, find F1. How will you find out? We know that F3, if it is, then the formula will be F3 equal to 3F1. So F1 will be F3 divided by 3. So 150 divided by 3 will be equal to 50 hertz. That is your F1, right? Now to find F5, it will be 5 multiplied by 50. So this is 250 technically,
Okay, makes sense.
right?
I need one more example.
Okay, let's do that. There are questions, don't worry. I will provide you questions. But do you understand that?
Yeah.
Yes.
Good. Okay. See, the answer is 250 in that. Okay, there is one more type of formula in here. This is the formula when the speed of a wave traveling along a string with two fixed points. In this case, the velocity will be given as V is equal to root tension upon mu. This is T, this is mu. Mu means mass per unit.
Oh,
Mass per unit length. Right? Kilogram per meter. That is the unit of this mu. Clear up this?
Yeah.
Now check this one. This is only and only when tension and all the things are given. Otherwise, you will use the basic formulas. All right. Now check this out. Now for this one, let's try that. They say a git. Try that. This is saying a guitar string mass 3.2 grams. I'm writing the data here. So mass is equal to 3.2 grams. Let's change it into kilograms by dividing it by 1000. 0.00. And the length 90 centimeters is fixed onto guitar. So length is given 0.9 meters. The string is tightened to a tension of 65. So this is 65 Newton. So Newton between the two bridges at a distance of 75. This is the length of a string which is given. Now what they are asking, calculate the frequency of the first harmonic. So you need to find F1 and produce when the string is plucked. Okay. Now this is interesting. You need to find the frequency. Now what is the formula in general for the frequency F1 when the length is given and everything? NV, and now it is NV, but here there is no N, right? So it will be V upon 2L. So I think you better find the V value first. For V, this mu needs to be found. This is mass per unit length. Mass is how much? 0.0032 divided by length. Length is 0.9. What is the value?
It's 3.5 3.56 times 10 to the power negative 3.
3.5,
6.
10 raised to the power
Negative 3.
negative 3. And this is kg per meter. Now we need to find the V value. So V will be equal to root 65 divided by 3.56 into 10 raised to power minus 3. Can you find me that value, please?
It's 18,000.
No.
After taking a
It's
root,
Oh, root.
135.21.
Yeah.
135.21.
21.
And this is velocity, so meter per second. Now place the values here. It's 135.21 divided by 2 into length is 0.75. So what is the answer?
Um, 50.7.
50.7. If you round it off, it will be 51 hertz.
Yeah.
This is when you have a mass attached to a string. Then you will use that formula. Check this out. They have done, sort it out. But why frequency is coming 90? Maybe you give me some wrong value. Check it out. Some calculation error.
They have 1 over 2 times 75 times 10 to the power negative 2.
Everything same. So the value must be some value you are providing me, some value must be wrong. Check it out, please. Calculation.
Okay.
I think your V value is wrong. Check it out. Small calculation and the answer will be wrong.
135.21 is still right.
Okay. Then why the can try this one calculation? Why the calculation is coming 90 and our answer is coming 50.7?
Wait, so aren't they using a different
Oh yeah,
equation in
I
step
fixed
2?
it. Frequency is wrong.
Oh,
The
this
frequency
one,
is wrong.
whatever is
Yeah,
written here is wrong.
I
So our,
fixed it.
so our,
90.1114.
okay. So is it right or we are right?
It's right. I just got the frequency wrong. I told you the wrong frequency.
Okay. So it's not 50.7, but it's 90, right?
Yeah. 90.139, yes.
So do you understand that now?
Mm-hmm.
So basically, how many formulas we have learned in this standing wave? One formula is for the velocity, not velocity, I mean for the frequency, which is NV divided by 2L. I want you to write these formulas so that you will remember that. Remember that these formula, when you will have both the ends of the strings are restricted. Wave cannot pass from those 2 points. Then and only then you will be able to do this. Okay. Otherwise, you can't use these formulas. Then a bit different. Like resonance is a topic which we will do. I didn't do it with Mahnur as well, which we will do together. All right. All together. This is your frequency. And then for the velocity, when a body mass is attached to a string, its V will be equal to root tension upon mu. So the formula will be, the basic formula will be 1 upon 2L into root T upon mu. But it's better